Mathematics, Mathematics, the bridge to innovation and progress, emphasizes how mathematical principles underpin advancements in science, technology, and innovation. This day serves as an opportunity to inspire young minds, promote problem solving skills, and celebrate the beauty of mathematics. So, this has been considered as the theme of National Mathematics Day 2024. And now, with these words, let's move to our next speaker, Professor Anokilal Pathak, Head Department of Mathematics, Brahmanand PG College, Kanpur. His area of expertise is complex analysis, mathematical modeling, Indian mathematics, Vedic mathematics. He has 37 publications to his credit and has produced number of PhD and MPhil students. And to his credit, he has awards as National Builder Award in 2020, Vibha Excellence Award 2019, and he is member of Indian Math Society and American Math Society. And his title of talk for today's lecture is A Light on Ramanujan. So, Professor Anokilal Pathak, sir, we welcome you on behalf of Department of Mathematics, Central University of Kashmir, and we are pleased that you had agreed to our invitation and you will be delivering today talk in this Zoom meeting on A Light on Ramanujan, as we are celebrating the birthday of Ramanujan, a great legendary Indian mathematician. Sir, please.
Thank you, ma'am. May I audible?
Yes,
Yes,
sir.
sir.
You are audible.
Yeah. I am very much thankful to Honorable Vice Chancellor of Central University of Kashmir, Dean of Physical and Chemical Sciences, Head of Department, Professor Bhavkar sir, our Speaker, Professor Borse sir, and all dear participants. Today, we are remembering great mathematician Ramanujan. Yesterday, a very important day was World Meditation Day. That was recently announced by UNO. So, first I am starting my lecture with chanting of Om. 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 And fact of Om, chanting of Om, along with Anlom Vilom Pranayam, this research paper is published by Dubai. Now I am coming. What is mathematics? Dear participant, mathematics is an expression of the human mind, reflects the active will, the contemplative reason, and the desire for aesthetic perfection. Its basic elements are logic and intuition, analysis and construction, generality and indivisibility. Here, one word is given very important, intuition. This word is very relevant for great mathematician Ramanujan. When Hardy asked him, these results, very important results, how are possible? He said, in dream, my Kuladevi. So, in a modern sense, we can say in psychological way. This is process of intuition. And through intuition, because Ramanujan was not a trained mathematician, through intuition, he gave more important results for us. Now, some Indian contributions of India, basic idea of introducing the place value system and the number zero, the credit for which goes to ancient India. Of course, large numbers have always been favorites of Indians at all epochs and are mentioned in Vedic literature in the epics like Ramayana and Mahabharata also. In Hanuman Chalisa also, Jug Sahasra, Jojan Par Bhanu, Lilio Tai, Madhur Phal Janu. Here we see the distance of the sun is same as that mentioned in Hanuman Chalisa. Now here Himalayam Samarabhya Yavat Indu Sarovaram Tam Dev Nirmatam Desam Hindusthanam Prachachate. Here we are looking map of ancient India. Kashmir is head of our India, and Kashmir is most important for India from ancient time. If we see Kashmir on behalf of our ancient time, Kashmir was very powerful center of trade and knowledge. About our discovery, great mathematician, French mathematician Laplace said, how grateful we should be to Hindus. Hindus means all people of Hindustan, who found this great decimal system which does not occur to the minds of such mighty mathematicians as Archimedes and Apollonius. Professor G.B. Halstead said about zero, the importance of the creation of the zero mark can never be exaggerated. This gives to Erie nothing, not merely a local habitation and a name, a picture, a symbol, but helpful power. It is the characteristic of the Hindu race whence it sprang. It is just like Nirvana into dynamos. No single mathematical creation has been more potent for the general on go of intelligence and power. In Harappan culture, we are very well known with knowledge of weights and measures because there was a very beautiful town planning, also knowledge of geometry as in form of circles, triangles, knowledge of brick building technology, and as mentioned about Vedic period. So I am coming here. We see father of Vedic mathematics, Bharati Tirji Maharaj, who have studied more and more Atharvaveda. And when we see Atharvaveda, our first verse of the Atharvaveda is ये त्रिसप्ताह पर्यंति विश्वारूपाण विव्रतः वाचस्पतिर्बला तेषाम तन्वो अद दधात में. Means everything is based on two numbers, 3 and 7. So if we define this, explain it, we find that everything is composed by either 3 or 7. Here we are looking about two mathematicians who gave their contribution in Indian independence. One is Swami Bharati Kastirji Maharaj, who participated in Khilafat Andolan and arrested in Karachi case. And other well-known we know about Bal Gangadhar Tilak. He was teacher and professor of mathematics in Ferguson College, Pune. He taught mathematics until 1890. Now, we know about some Jan's contribution as Borse sir told us about this. Now, I am coming on. Yes, Professor G.G. Joseph, written in book Crest of Peacock, Non-European Roots of Mathematics, that Indians predated Newton discovery by 250 years. Calculus is given by Madhvacharya Infinity Series, also Bhaskaracharya. Calculus is given by, as Borse sir said already. Now, Madhva, Kerala School of Mathematics, Nilkantha, and we are giving you some comparison. Bodhain diagonal square theorem in BC 800, that was given by Pythagoras in BC 540. Varamir Trilostak, known as Pascal triangle. Brahmgupta equation, today known as Pell's equation. Virahang series, known as Fibonacci series. Mahavira formula for combination, known as Harrigan formula. Bhaskaracharya formula for relative difference, today known as Rolle's theorem. Madhav theorem, today known as Gregory series. Madhav's pi series, today known as Leibniz expansion. Narayan Pandit method of factorization, today known as Fermat's result. Bhaskaracharya greatest common divisor method, today known as Euler's division algorithm. Nilkant summation, today known as Euler's similar results. Brahmgupta volume of frustum of cone and pyramid, known as Kepler similar results. Now, I am coming on our great mathematician, Srinivas Ramanujan. Srinivas Ramanujan was born on 22nd December 1887 in his maternal grandmother's house in Erode, a small town about 250 miles southwest of Madras. A year later, his mother, Komlata Ammal, returned with him to her home in Kumkodam, where her husband was a clerk in a cloth merchant shop. In October 1892, Ramanujan enrolled at a local primary school in Kumkodam and attended several different primary schools in the following years. In January 1898, having passed his primary examination with distinction, he entered the town high school of Kumkodam. It was in his later years at this school that he borrowed a copy of G.S. Kerr's Synopsis of Elementary Results, Pure Mathematics, which by its concise style strongly influenced his mathematical writing. In 1904, Ramanujan entered the government college Kumkodam with a scholarship. Up to this point, he had done well in all his school subjects, but gradually he became more and more absorbed in mathematics and neglected his other studies, so that his scholarship was not renewed. In 1905, being in monetary difficulties and depressed, he ran away to Visakhapatnam without informing his parents. By the following year, he had returned. He enrolled in Pachiyappa College, Madras, and attended lectures there for 3 months in an effort to pass the first art examination, which would enable him to enter the University of Madras. However, he failed in all his subjects other than mathematics. In 1909, his mother arranged a marriage between him and S. Janki Ammal. And by that time, this he posed and soiled in the recently founded General Indian Mathematical Society for 6 weeks. Probably in 1911, Ramanujan held a temporary job in the Accountant General Office in Madras. And through the generosity of R. Ramchandra Rao, the collector of Nellore, who was an uncle of Ramanujan's friend, R. Krishna Rao, he received some regular financial support for approximately some year. The year 1912 was a turning point for Ramanujan. He applied successfully for a clerkship in the account section of the Madras Port Trust at a salary of 30 rupees per month. The post was obtained through the influence of R. Ramchandra Rao and provided Ramanujan some leisure time to pursue mathematics. The chief accountant of the Madras Port Trust, S. Narayan Iyer, had been trained as a mathematician, and he and the Port Trust chairman, Sir Francis Spring, took a warm interest in Ramanujan and his mathematical abilities. Ramanujan was now well known to professors in various colleges in Madras, and they were anxious to help him to further his studies and foster his genius in a more suitable environment. The first step was taken by C.L.T. Griffith, a civil engineer professor at Madras Engineering College. He was a graduate of University College London and wrote to his former mathematics professor M.J.M. Hill enclosing some Ramanujan work. Hill's reply was meant to be encouraging but was not very helpful, possibly because he was put off by Ramanujan's unexplained summation of divergent series. Very important work. However, by this time, other more important figures such as Sir Francis Spring and Sir Gilbert Walker, who was a former senior wrangler, added their weight, and three well-known Cambridge mathematicians were approached. They are Professor H. F. Baker, Professor E. W. Hobson, and Mr. G. H. Hardy, the Calais lecturer in mathematics and a fellow of Trinity College. The first two evidently offered no positive response, but Hardy's reply was favorable and encouraging. It should be remarked that it is not known whether Baker and Hobson received the same wealth of material that Ramanujan sent to Hardy. Hardy at once established a rapport with Ramanujan, and several letters passed between them. Madras University was persuaded to grant Ramanujan a scholarship of 75 rupees per month for 2 years, and Hardy took steps to arrange for Ramanujan to be brought to Cambridge and receive suitable financial support. Various difficulties had to be overcome. To certain Orthodox Brahmins crossing the ocean from India to England makes one an outcast, but eventually agreement was reached between Ramanujan and his mother that he should go. In reaching this decision, the role played by E. H. Neville, a young fellow of Trinity who had been invited to lecture in Madras, was an important one, and he obtained Ramanujan's confidence. Therefore, on 17 March, very important, on 17 March 1914, Ramanujan set sail from Madras for England, supported by a scholarship of 250 pound a year from the University of Madras and 60 pound per year from Trinity College. This was adequate not only to support him in Cambridge but also for the family he left behind in India. Soon after his arrival in London, Ramanujan moved into Neville House in Cambridge. Some weeks later, he took up his rooms in Trinity College. Being a strict vegetarian, he never ate in the college hall but cooked in his rooms. As it was wartime, there were very few students in residence, and gradually many of the senior Cambridge mathematicians, such as Hardy's colleague J. Littlewood, departed for war service. Also, vegetarian food, which even in normal times was hard to obtain outside London, became even scarce. However, Ramanujan met Hardy nearly every day, and the discussions and collaboration with ensued were of immense value to both men. It was a very fruitful period. Unfortunately, early in 1970, Ramanujan fell ill, and during his remaining time in England, he was rarely out of nursing homes, first in Cambridge, then near Wells, and for a long period in Matlock in Derbyshire. Latterly, when he seemed to have improved slightly in health, he was a patient at Fitzroy House in London and at a sanatorium in Putney. He may have resided in other nursing homes of which we have no record. Improvements in health, such as they were probably due to his elections in 1918 to fellowships of the Royal Society and Trinity College. On 13th March 1919, Ramanujan returned to India. But he was clearly a sick man, and further, he died on 26 April 1920. Ramanujan was still working on his mathematics 4 days before the end. It is very important commitment of Ramanujan for mathematics, and as we know, his very well-known letter to Hardy, first letter to Hardy, here first letter to Hardy, and very important thing in this letter is Ramanujan said, my friends who have meaning to Eulerian second integral for all values of n, my friends who have gone through the regular course of university education tell me that gamma function, about gamma function, we are well known that gamma function is uh, valid for all positive integers, but it is not true when n is negative. So, Ramanujan give, I have given meaning to these integrals and under to be universally true. I have given meaning to these integrals and under the conditions I state the integral is true for all values of n, negative and fractional also. This is first letter of Ramanujan to Professor Hardy, and you can study this through uh, Google, and one book also, Ramanujan Letters and Commentary, and by Bruce C. Bunt and Robert A. Rankin, and this is published by East West Press Private Limited. And this is answer from Hardy to Ramanujan. And very important work is given in these letters. We know very well Srinivas Ramanujan made major contribution to the analytical theory of numbers and worked on elliptic functions, continued fractions, infinite series. Ramanujan prime, Ramanujan theta function, partition formula, and Mach theta function. Very important. It is so important. It is similar as Mach Jacobi forms, which is used mostly in quantum black holes. So Mach theta function is very important for us. His published and unpublished works have kept some of the best mathematical brains in the world. Ramanujan, in Ramanujan home state, 22 December, State IT Day And our Prime Minister Manmohan Singh in 2012, 20 December, announced as National Mathematics Day. Ramanujan Institute was started by Dr. Algappa Chetiyar in 1950 as a memorial to Srinivas Ramanujan. And during 1957 to 66, the Department of Mathematics and Ramanujan Institute of Mathematics were functioning as two independent bodies under the University of Madras. In 1967, these two were amalgamated to form UGC Center for Advanced Study in Mathematics and named as today Ramanujan Institute for Advanced Study in Mathematics. We know very well about Ramanujan, and so I think if we have to discuss some problems of Ramanujan, Bapkar sir, I have some time.
5 minutes, sir. You have
Yeah,
5 minutes.
5 minutes. Okay. So I am giving you some idea about Ramanujan works, divergent theorem. Yeah. Yeah. Here Ramanujan gave some series as 1 minus 2 plus 3 minus 4 dot value of this is equal to 1 upon 4, and solution of this is also given, but I am only informing you about the divergent series given by Ramanujan. 1 minus factorial 1 plus factorial 2 minus factorial 3 plus dot is equal to 0.596, and 1 plus 2 plus 3 plus 4 plus dot is equal to minus 1 upon 12, 1 cube plus 2 cube plus 3 cube plus 4 cube plus dot is equal to 1 upon 120. So these are some divergent series, summation of divergent series given by Ramanujan. And when we look at this series and solution of this series, it will be beautiful. And now I think, Bapkar sir,
Yes, sir.
my lecture is over, and I am very much thankful to you and also your colleagues and your university. Thank you very much.
Thank you very much, sir, for giving your time and shedding some light on the life and contribution of Ramanujan. Actually, I have gone through various lectures given by you on Ramanujan and Indian mathematician, contribution of Indian mathematicians to the society. And I feel that all lectures are very nice. Even we have discussed many times, I have discussed with Borse sir also, because what Pune University did, they had given project to PG student to write one just write one profile of great Indian mathematicians, and they collected many results of